Atkinson Center for Sustainable Future. I'd like to welcome you all here today and say thanks for coming to our event. This is the first time that Atkinson Center has taken part in the New York City Climate Week, and we're super excited to be here. My name is Lindsay Anderson. I'm a professor of biological and environmental engineering at Cornell, and I'm the faculty director for energy at the Atkinson Center. And so what we're going to do is welcome Adam Zarofsky, who is the Deputy Secretary for Energy and Financial Services in the Office of Governor Andrew M. Cuomo, who's going to say a few words about the Empire State's energy goals over the next decade. Thank you, Adam.
Thank you. If I close this, is going to kill your crowd.
That's how we figured it out. Fine, Adam.
Yeah.
We can get it.
That'll set us back about a half an hour.
Everything, exactly.
Good.
Well, thank you, Lindsay. Thank you, the Atkinson Center, and our friends at Cornell for having me here on behalf of the governor. Along with my partner, Richard Kalpin, some of you may know, I lead our efforts here in the state around energy. And of course, that is a very broad topic. And I think one of the challenges that constantly comes up is the energy needs of today, which are increasingly under stress, and of course the planning for tomorrow, particularly in light of climate. Let me just welcome everybody to Climate Week, because as Lindsay mentioned, this is probably the first time, it sounds like the first time Cornell's participated, but it is the 10th Climate Week. It is also the first time in my memory that the UN has decided that Climate Week and the General Meeting are going to be in the same week. And so, not quite sure what lesson they're trying to teach us other than it's difficult to get around the city, but it's hardy of you to be here, so we very much appreciate it. You know, New York State and Governor Cuomo obviously have been at the forefront of trying to lead the transition from the energy system of the past to the clean energy economy and system of the future. And it's pressing that we do so. There is I think little doubt among those who have studied the issue that the energy sector is going to be perhaps the largest contributor to our fight against climate change, which is pressing. I was recently 2 weeks ago in San Francisco representing the governor at the Global Climate Action Summit, which was terrific, but it also stressed two things to me that are important, right? One was the absolute necessity of acting now. And the second was the role of states, and let's just put it this way, the word they said that was the word of the year in climate circles was subnational. And that's code word for not the federal government, right? But that doesn't just mean New York State, it means New York State and its friends and partners and collaborators like Cornell, like others who can pull the weight. And I was struck, Richard and I actually had the pleasure of attending a meeting on the second day, I guess it was, of the summit, with representatives, energy ministers and representatives from the UN, from the EU, from China, from Canada, there was 20-odd countries or entities around the table, along with our partners in the United States Climate Alliance, California and Washington, to talk about collaboration. And what was stunning about that was that these folks around the world were really looking to the Climate Alliance, and in particular the 3 lead states, us, New York, California, and Washington, as in some sense a stand-in for what's happening in the United States. And that's not just in terms of actual technology developments and opportunities and what we can all do together on the ground, but also symbolically. There was a story told by the minister from the EU, energy minister of the EU, about when they got word that President Trump was going to pull out of the Paris Climate Accords, and then, as you may know, and I remember the day well, an hour later, the Governor Cuomo, Governor Brown, and Governor Inslee were able to announce the formation of a state alliance that is now 17 states, 40% of the GDP in the country, and all the rest of it to stay in. But what was interesting is we didn't really think about that internationally when we did it. We were just sort of reacting to what are we going to do now. But he said that in Europe and in other places, there was some, if the US is out, do we really want to, they felt some push, do we really want to invest in this? Do we really want to make our own commitments here? And that when they heard the states were in, and they heard that it was not monolithic here in the United States, and that it was helpful, at least that's what he was saying, to keep moving progress forward. So I think Governor Cuomo in New York State takes it very seriously, not just our need to transform our own energy system here in New York State, but also to continue moving forward and show a leadership role nationally and internationally. A couple things Lindsay mentioned, our energy goals and our energy works in progress. Just highlight a few things for you. I've been in this role about 18 months, and I remember when I first joined up, I was sitting with the governor and other people about all of this, and some of you are familiar with our REV program, some of you are familiar with the Clean Energy Standard, some of you are familiar with the Green Bank, and I can take you through all those things. But the question I asked, and perhaps naively, was, look at all these amazing things you guys are already doing. What's there left to do? And the answer to that question is everything, right? And everything means actually executing and actually bringing about. It's nice to talk about REV and how we're going to change the utility business model to make them more a part of market-based solutions to bring about the change we're all looking for. But actually doing it, right? Demonstrating pilots, bringing in academic leaders to help identify pathways that can be tried. Afterwards, documenting and of course, publicizing the successes of it. And the same thing is true across the board. We recently, you may have read, well, you're probably familiar, we had a program called the ZEC program to try to keep alive some upstate nuclear facilities, which caused some controversy, but was really about ultimately the state's ability to combat climate change, because if those facilities rolled off because of economics, they were going to be replaced, at least now, with fossil plants. And that, of course, is going to produce a new lifespan for those plants, and how do we transition those? So the governor proposed a program, the ZEC program, to try to help those plants stay alive. And you would think, boy, that's a tough road to hoe. It is, because it costs ratepayers some money, and there was some uproar about that. And then there's been litigation about that. And it was only this week that the Second Circuit finally ruled that the state did, in fact, has the right to do the program. But it only demonstrates to me how hard this is going to be, even in a state like New York, where the inclinations are, and everybody says, yeah, I know, climate change, but not here. Or but not on my bill. But not, not today. So it's so grateful, I'm so grateful to be here, and so grateful for Cornell's partnership and participation, because all of us together obviously are going to have to row to make this happen. We have a clean energy mandate right now of 50% of our electricity by 2030 coming from renewable sources. We have greenhouse gas emission targets of 40% reduction over 1990 levels by 2030, 80% by 2050, and that's the minimum of what we need to do. And so one of the things I was just talking with Todd and some of the folks before is start to change mentalities. It's not just about policies in place, it's changing the mentalities. And the story I'll just tell you, we were talking about how utilities can and should be embracing, for example, the move to electric vehicles, because at the minimum level, it's not about climate change, it's about a whole new product line, a whole new demand channel for their services. So how do we get them there? And I was sort of struck, I told this story before at panels, but I think it's a good one, recently by a comment from my now 4-year-old daughter, when we were in a car recently, and we own an electric vehicle. And we were driving somewhere, and I come at it thinking electric vehicle is kind of a newfangled thing that's different or cool or whatnot. And I said, well, I have to stop off. We got to use the restroom, but I said, let's go get some gas. And my daughter from the back said, silly daddy, we don't use gas, we use electricity. Right? And the point of the story to me is that because she's never known anything else, because she thinks about it that way as the standard, she thinks I'm silly. Well, how do we translate that to a broader population in New York State? So I appreciate your efforts in helping us do that, and I look forward to continuing working with you. So thank you very much for your time.
Thanks, Adam. Yeah, so as Adam noted, New York State's really pioneering the way both in sustainable energy and economic development, and trying to do that now, not later. So just before we get started, I want to take a couple of minutes to talk about the Atkinson Center for those of you that maybe don't know about us. So the Atkinson Center is a multidisciplinary, inter-collaborative center that is looking for solutions to sustainability challenges around the globe. We're comprised of 500 faculty fellows across 12 colleges, 90 departments, and Cornell Tech. Okay? So by funding cross-college projects and partnerships, With nonprofits, government, industry, the Atkinson Center supports pioneering researchers across all disciplines, sciences, engineering, social science, humanities, and the arts, towards advancing sustainable solutions. Just while we have, and obviously we have a long history of working towards accelerating these energy transitions, both in New York State and the nation and globally. Just quickly, our director of the Atkinson Center, David Lodge, is sitting at the back, if you'd like to say hello now or later.
Thanks to Lindsay for her leadership.
Yeah. So I'm going to also introduce our panelists. Over here, we have Jeff Custer, who is the Kroll Professor of Integrated Energy Systems at Cornell in the Department of Chemical and Biomolecular Engineering. He's also the Principal Scientist for Earth Source Heat. Todd Cowen, he's a Professor of Civil and Environmental Engineering at Cornell, and prior to me, he was the Faculty Director for Energy at the Atkinson Center. Next, we have Lara Skinner, who's the Executive Director of the Worker Institute with the ILR School at Cornell. And finally, we have Trey Taylor, who's the co-founder and director of Verdant Power and president of Verdant International. So we have a quick video that we're going to show you before we get started.
The state of New York is addressing the imminent threat of climate change by requiring 50% of the state's electricity to come from renewable energy sources like wind and solar by 2030. Cornell University researchers are playing a vital role in helping the state, as well as the rest of the US and the world, meet the incredible demand for generating sustainable energy in the coming decades. Not far from where we are today, near Cornell's Tech campus on Roosevelt Island, the Atkinson Center for a Sustainable Future has been working with Verdant Power on the Roosevelt Island Tidal Energy Project. This project uses free-flow system turbine blades to capture energy from the East River's strong water currents. While we search for new, more efficient, and environmentally friendly renewable energy sources, Cornell is working with communities to reduce the need to create as much energy. Cornell researchers have created an energy-smart community pilot program that equipped 12,400 properties in Tompkins County with smart meters last fall. These meters, paired with a new online energy manager, allow consumers to access their energy use data. By enabling households to measure and manage their own electricity use, this project has the potential to lower consumers' electric bills, reduce emissions, and create a more equitable pricing system. Energy monitoring technology is also important because it can help identify inefficiencies in supplying power. This is a crucial issue in the US, which is responsible for nearly a quarter of the world's total energy consumption, with nearly 15% of that going to heating homes and water. Burning fossil fuels creates more energy than is needed to keep your house at a comfortable temperature in the winter or warm your shower water, leading to unnecessary waste and a larger carbon footprint. Therefore, Cornell is taking a cue from Iceland and looking to geothermal energy to efficiently heat and power its campus. Geothermal energy is a clean, reliable, renewable source of energy that uses heat stored in the Earth's crust to heat buildings or generate electricity. Cornell scientists have studied large-scale geothermal systems around the world and are exploring ways to develop deep geothermal technology closer to home. Scientists will start by gathering data and studying rock formations beneath Cornell's Ithaca campus. Next, to reach the hottest rocks in our region, scientists would drill a 2 to 4 mile deep test well. The well will be safely enclosed with the highest quality casings, cement, and other materials to protect the environment. Only after successful research, safety precautions, community engagement, and other approvals would scientists drill a second well to complete the system. This would allow water to be slowly pumped into the earth where it would be naturally heated, pumped back to the surface, and circulated through buildings on campus. While this is an exciting project, it will take years of careful research and planning to implement. If successful, it will heat our entire campus and create a new, renewable energy industry capable of sustainably meeting heating challenges throughout New York State and beyond. We're going to talk about first some of the technologies that are developing at Cornell and in New York State.
And so I'll ask a few questions from the panelists, and then at the end we'll open it up to questions from everybody. So first, let's talk a little bit about the new technologies. So Trey, I understand that Verdant Power is developing tidal resources in the East River now. Can you tell us a little bit about the scope and status of that project?
All right, so let me explain about the technology, but preface it first with this. I'm a businessman, and I look at the three factors that are driving the world economy. It's globalization, it's the IT revolution, and it's climate change. And so Verdant Power's mission is to help build sustainable communities. But our focus is on water, and water is the #1 critical issue in the world. So what we've been doing in the East River since 2000, we put in the world's first grid-connected array, multiple turbines, in the East River in 2007. We had all the funding we needed to take it to full commercialization in 2007. And by the way, when it comes to infrastructure technology, on average, it takes, going from a working prototype to commercialization, on average 10 to 12 years. And there's a rigorous engineering steps called technology readiness levels. So if any engineering students are here, you have to understand that's the rigors you have to go through to get to commercialization 9. So 2007, we put the first grid-connected array and all the money we needed. 2008 happened, global economy. We lost all the money we needed to go to commercialization. So it slowed us down in the development, but we're making headway nonetheless. So what's happening in the East River now, we just received another grant from the Department of Energy. It'll take us to full commercialization. Our business partner on this project is NYSERDA. So that's what we're working with. And where we are now is in the final stages of commercialization of a grid-connected array of technologies in the East River, which will go in 2020. What I've been working on the international side is where we'll be going to export this technology once we show it operating in the East River. One more thing to share about our technology, and I'll be talking about this later, I'm sure some other questions will come in this regard, but as a result of our success in the East River with tidal power, and by the way, these technologies are designed not only for tidal power, but for ocean currents, river currents, large canals. What we're doing is just harvesting the hydrokinetic energy from the water, converting it to mechanical power and electrical power. As a result of that success, one of our engineers now leads the International Standards Committee set on renewable energy, but it's based on what we've done here in New York. So I want to share that mention of the world standards are what we are the pioneers have accomplished. So there's a quick summary for you.
That's pretty exciting. Yeah. Thank you. So Jeff, let's go with you next. As we mentioned in the video earlier, that Cornell has some pretty ambitious climate goals. We'd like to be carbon neutral by 2035. In fact, we intend to be carbon neutral by 2035. And so, Jeff, why don't you tell us a little bit about the Earth Source Heat Project that's going to, I think, be a linchpin in this plan.
Right, so let me first give you a little introduction to why this might be important for New Yorkers in particular. Electricity from renewables can come from a lot of different sources. We have a lot of need for that here, but not as much need as you might think. If you look at the carbon footprint of New York State, and you ask the question, how might I reduce that? Not just with renewables, but in general, and ask the question, how much of that comes from generating electricity? What do you think might be the answer to that question? Do you think it's 50%?
100%.
100%. Well, what if I told you it was 17% of the carbon footprint of the state? So if we were to, and I think we should, if we're certainly going to level that out with a very aggressive renewables program, that won't solve the next goal that the governor has, which is to get to a very low carbon footprint. So where's the rest of it? Well, a good chunk of it's in the vehicles we drive, for sure, about 40%. The other 40%, though, is in heat. And not necessarily the kind of heat that's running and melting metals, but the kind of heat that we all use in our homes every day. And that is used in lower temperature industrial uses in this state. We make a lot of yogurt and cheese and things like that. So if I look at ways in which I'm going to get that, there aren't a lot of options open. You could burn wood, which probably isn't going to be the scalable thing for doing in the state, or combust wood. So we started looking at the earth itself. And a number of you have probably heard about heat pumps, geothermal heat pumps. This is very different than that. Cornell's a big place. It has 30,000 of us wandering around. So one of the key things that I try to tell our students when we're in class is the issue of scale. And you can do this at individual houses. I'm doing it at my house right now with the geothermal heat pump, but it's hard to do on the campus in the kind of scale we need. The estimates we've come up with would say we've got to put in 10 to 20,000 heat pump poles to do that. So the scale issue can be addressed by this earth source heat, as we're calling it, because we're taking water out and circulating it through Cornell's district energy system at a much higher temperature than we could take out of the shallow ground and use it directly for heating the buildings. And this does have some opportunity, as you'll see, and I think you saw from the video, for the state as well. So that's one of the reasons we're very interested in it. I think when we come back to this, we'll say a little bit more about how it's connected to growth in the state and as well as in the country, and how come we haven't done this before. So.
Okay, so speaking of doing it before, Todd, I'm going to ask you about the Energy Smart Community, but first, Cornell has done this before, right? So Cornell is really interested in looking for sustainable ways to sort of manage their campus real estate. So do you want to tell us just really quickly about the lake source cooling project that started quite early on, and then we'll move into...
Sure. So as many of you may recall, the Montreal Protocol required us to reevaluate how we were cooling spaces, or at least what gases we were using, with CFCs being phased out in 1999. So Cornell did due diligence on 3 ways to figure out how to cool its campus. Again, as Jeff mentioned, of 33,000 people. And we have significant cooling needs despite being up in central New York. And they looked at replacing a CFC-free base system and using electricity. They looked at a ground source option, basically a geothermal heat pump. And they looked at using cold lake water, because we sit high above Cayuga's waters. And Cayuga Lake is actually deep enough that the deepest parts of the lake stay below about 42 degrees Fahrenheit all year round. And so it turns out we could pump that water through a heat exchange facility, just the same way Earth Source Heat plans to pump warmed water from deep in the earth through a heat exchange facility to heat a heating loop. We pump cold water from deep within the lake against a heat exchange facility to cool water that goes through all of our buildings on campus, and we have district cooling. We've had district cooling now for decades, but this was replaced in 2001 with lake source cooling. And so when we did that, we dropped our electric demand for cooling campus by 90%, or almost 90%. And in doing that, we also dropped the nitrogen loads and sulfur loads to the atmosphere and the pollution by that same 90%. So it's been a phenomenal air quality and electric reduction project, not to mention economically, it's saved Cornell a fair amount of money.
So, sure.
Yeah, so Todd's point's a really good one that I should have emphasized too, but now that you've heard about lake source cooling, if we were to look at Cornell itself and the electric load, it's about 30 megawatts of electricity. If we were to take the cooling load just for those few months of the year, it's comparable to that in the same sort of level of, and a heating load actually, on many of you may have been to Ithaca or spent time there, there are about 20 days of the year where it's really cold. And so the heating load is more than double in terms of the sort of units of megawatts of heat versus megawatts of electricity. So this is a really good example of something that is very applicable both for cooling and heating, and we can do it at the scale that I think would be useful. So it's, just think about how big this is. It's not a small piece of the total energy budget, even on campus.
Yeah, and a little bit later we'll talk about sort of how this extends
Sure.
out. And I want to know what Ithaca you're living in, where it's only cold 20 days of the year.
Well, really cold. I said really cold.
Okay.
Right, really.
But I digress. Todd, could you, so we talked about heating, we talked about cooling, and obviously electricity is still a huge part of our carbon footprint, not just at Cornell, but everywhere. So could you tell us a little bit about the Energy Smart Community project that you're leading?
Sure, and of course, picking up on what Jeff said about transportation right now is 40% of our footprint, and it's dominantly fossil fuels. The hope is a lot of that's going to transition to electric. So smart grid and how we actually get renewables into the grid, how electric vehicles and the lakes we use and all the electric systems we use are powered by that renewable electricity is a huge challenge going forward. The grid that we live with today is pretty much not unlike the grid that our grandparents lived with 50 years ago. So the Energy Smart Community is a demonstration scale project under this Reforming the Energy Vision, REV, which Adam Zarofsky mentioned as well, the governor's top-down initiative, to push the utilities to get uncomfortable in the sense that they need to think about how to transform this legacy grid into a 21st century grid. And so the Energy Smart community is 12,400 smart meters and a lot of data and a very sort of intense data network to help customers understand not only what their energy use is, but to leverage the fact that we now know what their energy use is at a very granular level, essentially on 15-minute intervals, how we might use that data to shift the way they use energy without them having to do anything, to make it as simple as you preset a few ideas about how you'd like to live, and a cloud-based computational algorithm would buy power from you when it's cheaper and shut down systems that you have when the grid is under high pressure, store it in a battery locally for you, charge your EV when electricity is cheap, not charge it when electricity costs are high, and accept all of those signals. So it's a really interesting opportunity to develop a test bed for researchers to work on, for the utility to use as their prototype for how they'll scale across the state, and for private sector partners such as Tesla and BMW North America, who are both part of what we're doing, and Tompkins County Cooperative Extension, which is the cooperative extension outreach arm of Cornell, was involved in helping really gather citizen input into the process. And the one thing I should mention, which hasn't come up yet today, is one of the great things about working at Cornell on these problems in the technology space is we have incredible social scientists. And most of these problems can be solved technologically. It's just money. The reality is we've got to get all of us to use them. And as we know, it doesn't matter how good a design is, if it was designed for a problem we don't care about, we won't use it. So the social scientists being involved really help us figure out what the appropriate pathways are and understand customers better and consumers better. And so they're very much involved with the Energy Smart community.
Thanks, Todd. So coming back to the community piece, I'd like to go to Lera now. So I know, Lera, that you've been working really closely with Governor Cuomo's office on workforce development in a sort of a robust, clean economy. So could you tell us a little bit about what all these sort of new technologies and the evolution of the energy space means for jobs and economic development? Thanks.
Yeah, thanks, Lindsay. So at my institute within the School of Industrial and Labor Relations, we really look at the labor and employment impacts of climate change and climate protection efforts. So we're looking at how many jobs will be lost in this transition to a more low carbon and sustainable economy, how many jobs will be gained, and what will the quality of those jobs be. So we sort of sit the world of work alongside of climate and energy issues. And when we do that, we see two crises that we're facing, right? We're looking at both the climate crisis and how do we quickly and dramatically reduce greenhouse gas emissions and avoid the worst impacts of climate change, but also how do we reverse inequality, which is also another major issue that we're facing. New York has the second highest income inequality in the country. We've got a third of workers in the US making under $12 an hour now. You know, we're still dealing with stagnation of wages following the 2008 crisis. So we really, when we come at this work, we really think about how are we solving both of those things. We also know that, you know, climate protection efforts have often been undermined or weakened because the needs and interests of workers and working people haven't been considered as we design these programs. And that sort of jobs versus environment frame, right? You can either have jobs or you can have the environment, but you can't have both. That's prevailed. So that's really kind of informed our approach. And so with the governor's office, I'll highlight three things that we've been doing. One is that we put in place to double the amount of money that's available for solar on schools and energy efficiency work in schools and public buildings. And we did that with a requirement for a project labor agreement, which is basically a standard for high quality work and a training pipeline to local and targeted communities. And so with that, you know, you're looking at how do we scale out the solar work that we're doing. We've got 4,500 schools in the state. How do we expand out the solar and energy efficiency work that we're doing to those schools and public buildings? Schools, their second highest cost is utility costs, so it's a huge savings for public budgets to be able to reduce the energy consumption in schools, and it also creates sort of a living laboratory for teachers and communities to have solar and energy efficiency work done in those schools. Second thing I'll mention is the state released some of their largest renewable energy procurements in the past couple of years, and they are now requiring a prevailing wage on all renewable energy projects in the state. So again, this is ensuring that there's a wage standard for this work, right? That it's going to be high quality jobs that are created, which speaks to the point around inequality. And then the third part I'll mention is on offshore wind. We've been doing a lot of work there. The governor's taken major steps in NYSERDA towards developing a long-term, large-scale offshore wind program. And for us, we're really looking at it all the way from manufacturing to the ports work to the construction and operations and maintenance. So the majority of work in offshore wind industry is in manufacturing, right? Manufacturing the component parts, and then in the specialized ports that are needed to support this industry. And the governor and the New York State Energy and Research Development Authority released a draft RFP for the offshore wind that they're going to be procuring this year and next year, which is sizable. It's 800 megawatts this year, it's 800 megawatts next year to meet the 2.4 gigawatt goal by 2030. And in that draft RFP, they're also looking closely at what are the economic development and job quality and labor standards that will be included in those solicitations.
Wow, that's great. Thank you. Okay, so Trey, I want to stick on this economics issue that Lara mentioned, this idea that we can either have, transition to a clean economy, or we can have jobs, or we can, have good financial economics. So, but you founded a for-profit company that's interested in really not just selling, renewable energy devices, but really transforming the energy space. So, can you tell us a little bit about why, what your thinking is on
Right.
that?
So let me pick up on what was just said, and also share another thought with you, which comes from Sir Richard Branson, who says there's no greater time to make wealth than now because of climate change. In other words, what we're dealing with creates jobs, tremendous amount of jobs. Think of how many solar power people are now being employed. So let me pick up on this for a moment on the economic side of things. The cost of renewable energy, particularly in wind and solar, is coming down. And the quite simple answer is the more megawatts you get installed, the more the costs start coming down to sort of mass manufacturing, scales of economy, etc. We work closely with NYSERDA, as I mentioned. And in our particular industry, marine renewable energy for rivers, tides, oceans, NYSERDA has identified over 1,000 megawatts for the state of New York alone. Just the state of New York, not alone the region. For every 1,000 megawatts of our technology, it will create 1,500 full-time jobs. So if you look at the potential for the world, for example, that's 250 gigawatts, 250,000 megawatts. A lot of job creation. Now, a fellow Cornell alumnus is here with me today. It's Ken Kramer. He and I both have been serving at the Department of Commerce on renewable energy efficiency. It's the idea of what we can do to export technologies and services, and if it's coming out of New York, that will create even more jobs. But it's what we're doing here with these showcase projects, demonstrating to the world, that will create suddenly an industry cluster coming together here in New York. And New York could be leading the world in renewable energy use and development. So I'm really keen and positive of what's shaping up here, particularly the way Atkinson Center is sort of driving it, coalescing it all. But I can see lots of jobs coming in, which really is the economic answer, while at the same time lowering costs for power and delivery.
Great, thanks. So sticking with that sort of idea of influencing outside of Cornell and New York State, Todd, I'll come to you next. So what's a specific example of how Cornell research in the Energy Smart community has influenced the state and the utilities?
Sure, I'll give two that fall under the case of the Energy Smart community activity in the last year and a half. So one is on the social sciences side that I was mentioning before. So getting people to adopt new technologies is challenging, and particularly if you haven't designed that new technology up front with people involved. And I think going forward we're going to see more and more of that, and Cornell's particularly interested in developing that design approach from the ground up. But smart meters have been around now for decades, and there are a number of groups that are very concerned about a variety of issues with smart meters, whether it be your data privacy, health issues because of radio frequency energies. And so coming in, there was a fair amount of skepticism about Avangrid, the local utilities' effort to put these smart meters in. And we helped work with Avangrid, with our social scientists, to help them shape community forums, answer questions, and how to work with the community. And in the end, there is an opt-in program of the 12,400 smart meters. All but 1.2% of people opted in to have that smart meter. And the reality is that's the lowest rate we've seen historically across all of Avangrid's networks. So it's a really impressive, I think, point that by working with social scientists to understand what the concerns were and how to communicate about those concerns really helped shape their business plan going forward as they look to now roll out smart meters statewide for them, about 1.5 million customers. So another example more on the technology side would be electric vehicles, which have come up a couple times already today. And so working with electric vehicles, the hope is to incentivize people to get involved with ownership or ridership in electric vehicles. And part of doing that is helping them understand how they might save money, of course, because it comes down to the economic argument that Trey was just making. And so one of my colleagues working on the Energy Smart Community in Electrical Computer Engineering, Ellen Batar, had a very clever idea about how to design tariffs, rate structures for charging your vehicle that would make it cheaper to actually charge your car and lower your fuel costs. And the utility was really interested in this because they wanted to, they actually were being required under REV to design a program that would incentivize electric vehicles. And so they have come together, and it took about a year and a half working with the Public Service Commission, but that rate was just approved the other day. And there will now be a test of this or demonstration of this rate structure, which is basically just saying, you let the utility know, I don't need my vehicle until a certain time tomorrow, and it needs to have a certain range. And the utility then has the option to charge and deliver that whenever you want. It's a contract to deliver that, but not the way we normally do things. I plug in my iPhone, it charges immediately. What if I plugged in my iPhone and it fully charged my iPhone by the time I woke up the next morning, but it did it at the cheapest rate in the middle of the night? That's what this new rate structure is. And it's an example of how this technology is going to be really helpful and scale within the state.
That's great, getting the utilities on board. So Jeff, coming back to resource heat and geothermal energy, I understand that geothermal energy has been around for a really long time. In fact, it was invented, right, in, I think you told me, Idaho?
In Idaho.
Right, in the 1800s? So why are we sort of, what's been the delay and why are we just hearing about it more now?
So this is, to provide some context here, I think a lot of you in the room know the important role New York played in the early development of America when we moved to the West. Well, I want to try to convince you that we've got to come back to New York to do some things that we started a long time ago. I usually put together 3 slides for this. First is invented in America. You've heard this story before. Boise, Idaho, the late 1800s, put in a geothermal earth source heat program in a way to heat the municipal buildings, the Capitol buildings, and now some of the other state buildings and municipal buildings in the city. Still operating today, a long time, more than 100 years, right? So we have something that we know can be done. So the second slide comes in, well, what happened after that? We had a lot of other options, so we sort of kind of gave up on doing geothermal across the board. So the country of Iceland, that you saw in this video, had no other options. They're sitting on a volcanic island. They had no fossil fuels, nothing like the endowment we've had in this country. And they had to import everything. So they imported coal, and they imported oil, and they had terrible balance of payments for one, but terrible air pollution, all other issues. The city, if you took a photograph in the 1940s and 50s of Iceland, it wouldn't matter whether that photograph was black and white or color, because the city looks like it's in a dark cloud, much like some of our early American cities did, as many of you know. But they decided deliberately to make a change. In about the 1950s and on into the 60s, they really perfected this. They dug up every street, put in the district energy system, used geothermal and hydropower, their 2 big renewables, to provide all their electricity and all of their heating. So they heat 90% of the homes in a pretty tiny place. There's 300,000 people in Iceland. To put it in context, it's only 10 times bigger than Cornell in terms of its footprint, but a lot smaller than America. So my thinking is, well, what else has happened since then, right? And so you got to look at the historical direction. The French, and we can't necessarily say they invented it, but they were smart enough to use it. And the Paris Basin has a relatively shallow geothermal system. They started heating homes in Paris a long time ago, and more recently have taken it to 1 million homes. And then beyond that, the story connects, I think, to the invented in America. The Chinese decided this would be a good idea, formed a partnership with the Icelanders, and they now have developed into the largest sort of international country. But they weren't doing it to lower their carbon footprint. They were doing it because the cities were unlivable, because they were burning coal and couldn't breathe, much the same way that the Icelanders proceeded. And so I think our reasons for thinking about this has a lot more to do with the combination of renewable energy, a more sustainable look at our climate sort of situation and trying to really mitigate the effects of that, and something that actually would have a lot of jobs with it too, by the way. You cannot offshore geothermal. You do it right there, and then the infrastructure involvement would involve a huge amount of opportunity for our aging cities and rusting cities in New York, state. So I think it's something that everybody would win in this if we thought through it. And I'm sorry that Adam missed this, but we'll certainly make sure he gets his picture, because if I were involved in state government, I'd be interested in this from the point of view of jobs and sustainability and meeting your carbon goals and renewable energy all at once. So
it's time now for us to
it's
sort of
time
get a
to kind of-
rescale.
Yeah, to
and
rescale
answer
it
that.
and start to think about why Cornell could play a role in that.
Yeah.
Thank you.
So Lara, I know you sort of gave us an overview of the worker and job training piece here, but can you tell us more about what the challenges are for the workers in this transition?
Yeah. So from a worker perspective, there's been a lot of talk about the potential for the creation of green jobs or climate jobs. But apart from a few states like California, they haven't materialized. It's been more sort of rhetoric than reality. Right now, the #1 fastest growing job in the U.S. is a wind installer. #2 is solar installer. So it's starting to change, but there are still concerns around job quality. In California, in the residential sector, the average pay for a solar installer is about $14 an hour, which is not living wage. So, still concerns about, how do we bring this stuff to scale to really see the level of job creation that we would like to see, and also the scale that we need, right, to tackle climate change and reduce emissions. The other piece of this is in New York, we don't have a lot of power from coal-fired power plants, but some states do and have tens of thousands of workers who work in the traditional coal, oil, and gas sectors. And you have to think about what are the negative implications as we transition away from those power sources to more renewable-based powers, and how do you protect and support workers and communities in that transition. Probably the best example we have right now of that challenge is the Indian Point nuclear facility. So that's a 2,000 megawatt nuclear facility up on the Hudson River. It employs 750 workers. And so there's a challenge there around, how do you transition these workers either to retirement or to new forms of employment, but also the big pieces around the community. So Entergy, the company that runs that plant, pays $30 million a year in school and property taxes. And so when you shut down that plant, first reactor in 2020, the second reactor in 2021, which is really not that far away, there's a big hole in the public budget there, right? And so then there's also another connection to jobs where that public budget is supporting police officers, firefighters, EMTs, teachers, right? The whole sort of gamut of employment connected to the public sector. And so, thinking about, how do we mitigate these labor and social impacts as we do this transition is really important. And in the past year, the governor's office set up what is called an Environmental Justice and Just Transition Working Group. And so I think this is a good example of how community, industry, state government officials, labor unions, other stakeholders come together and really try to more proactively plan the transition. What is this going to look like, and how do we support workers and communities as we do this?
So, as usual, we're running a little bit behind schedule. So what I'm going to do is I'm going to jump to the last set of questions, where we're going to think about sort of what are the broader implications of these things, and then we'll open to the audience. Okay. So Todd, quickly. That's a hint.
Yep.
So what opportunities do Cornell researchers see to lead the nation and beyond with the New York State REV framework that has developed, with the ESC?
Sure. So I think, in fact, as you well know, I think the next step that you and I see is that we actually want to leverage this test bed and the framework of New York State with the National Science Foundation large-scale project. So Lindsay has led a project actually on an engineering research center, which would essentially be a cluster of activities centered on, for us, distributed energy resources, but partnering with state entities. We were talking with Richard Kaufman's office this morning. We've been talking with Evan Zarofsky. We're talking with the various other government and state players, but also the private sector partners that would come involved, the communities that would be involved, and the social scientists and technological people and the policymakers to help create what the next set of standards and businesses opportunities might be, and basically workforce training and new businesses that would be that distributed energy resources business model. So that'd be a 10-year, $50 million vision for an incubator set of activities in central New York for the entire state of New York.
That would be really exciting. not that I'm biased. So Trey, I know we've talked before, and specifically you guys don't just think about, how do we make electricity, right? But so I'd like you to sort of tell people how your company sort of looks at the energy system more holistically globally, and touch on maybe some of your projects.
I think this is really important, and this could really be a game changer globally, which could be happening here in New York. So if you think about water is the #1 issue in the world, and it's the water, food, energy nexus that's critical to water management. So when you look at sustainable, the Atkinson Center, it takes that all into account. What we want to be doing for our project in Roosevelt Island, RIGHT project, is converting it into a living lab where we'll be demonstrating these things that come from water. For example, the Con Ed is very interested in tying in tidal power to its energy storage, because the tides are so predictable. They know exactly when to pull an energy storage, they know exactly when it's going to get recharged. I use that as an example. But the other things we're going to be doing is hooking up our systems with electrolysis systems to be extracting hydrogen from water for stationary fuel cells, another form of energy production. We'll be demonstrating that there, working with Cornell, sort of a living lab, and with students how we bring this together. Clean water systems, mechanical power pumping through electronic membranes, electric vehicle charging stations, so that New York City is the only city in the world that has tidal-powered cars zipping around its streets. These are all the kind of things that will be going. Now here's the important thing. Everything we're demonstrating there, also hydropower is distributed generation. We're also working with major property developers here in New York to take our power directly into buildings here in New York, if not onto Cornell campus or the Roosevelt Island itself. So here's where I'm going with this. Let's think of this as a big showcase, along with the other showcases that Todd and all have mentioned, but we're showcasing it in front of the United Nations. It's like a calling card on the world of what other governments and countries could be doing. We say, come on over, kick the tires, see how it works. All of this is scalable. And that's where we see a real opportunity working with Cornell here in New York at Roosevelt Island. So I'll give you that example.
Okay. And if you get a chance afterwards to touch base with Trey, he's got some really interesting projects in developing countries that he could probably fill you in on.
Yes.
Okay, so Jeff, quickly, the last question for you. If Surskit is successful at Cornell, what does that mean in terms of its deployment?
Well, I think just as we've heard from Trey, that there's nothing that beats demonstrating it at a reasonable scale, so that people can come and look at this and say, wow, you're now doing something that hasn't really ever been done in this part of the country, for sure. And it's working, not only from the standpoint of, we have full transparency. We want people to come and look at this. Part of it's our land grant thing, but we're also a university. This has got some research challenges to it, for sure. And so the ability to do this within this sort of living lab sort of view is a huge opportunity, I think, for us in what we can do for the community in the state and beyond. And we have support from the U.S. Department of Energy. They're interested in Cornell as a sort of a window into direct use for the country. And there are 50 states and lots of people who could benefit from this. Just look at the heating degree map that we have for the country. The northern tier of the United States has a big heating load. We've already have this lake source cooling. It would be good to see more of that kind of thing going on. So being able to come to the campus and witness a real project where we're not trying to protect intellectual property here as much as we are trying to get this message out that it actually could work. So I think that's a scalable opportunity that Cornell has got its arms around now, and hopefully it'll make it see it happen.
Good. Okay, so last question. So Lara, I know when we were sort of organizing this panel, you were in California for the Global Climate Summit. And Adam also mentioned, the other states, California, Washington. And so I wondered if you brought away any lessons from that meeting about what's going on in the other states that would be useful for us here.
Yeah, I would say in particular, a lesson learned from California is that they've sent a really long, loud, and clear policy message on their commitment to reduce emissions. They passed AB 32, their Global Warming Solutions Act, in 2006. So they've got a good amount of time under their belt. And they also did the economy-wide cap and trade system with it, which then produces the revenue to invest into to the type of efforts that we're talking about. So I just think that there's been a much more stable environment there for clean energy industries, and that has encouraged investment in solar and wind and other types of clean energy technologies. They've installed 30 times more solar than New York. You know, they've got almost 90,000 workers employed in solar. We have, 9,000 workers, and that's like the full gamut of the industry. So I just think, that's the lesson to learn is in New York, we haven't actually legislated our commitment to reduce emissions. We have some clean energy standard goals, but that's different than a legislated mandate around, reducing our emissions. And the California Air Resources Board has worked hand in glove with the California Workforce Development Agency. So they've also been able to really think through all of the training and workforce development issues that are needed to really support these industries.
That's excellent. Thank you. Okay, so finally, I'm going to open it up for questions from the audience to our panelists. So back there, yeah.
This is a question for Jeff. How far away are we,
Oh yeah, maybe if you could stand up when you ask your question, that would be great.
I'm Kim Earl, a current member of the Alumni Advisory Board for Sustainability for the Atkinson Center. And my question for Jeff is, how far away are we from a commercializable product? And what is the scale of it? So is it a municipal scale? Could this be done, for example, for a housing development with X number of units?
Good question, right. Yeah, so in terms of how far, at this point, we have a very good idea. You saw from the video, we're already pretty well characterizing the region in terms of its geologic character. We know we can drill holes into the ground that deep. There's plenty of capacity in this region to get that sort of capability, but it costs money.
Well, that's what I mean by commercialized.
That's the ROI. Yeah. So, but there's a different model here. Cornell is not trying to get a real rapid rate of return, so they're discounting, and their interest rate on a development like this is in the long-term interest of the university to sort of inoculate themselves from having to worry about natural gas prices fluctuating and going up, which is what we're living in a sort of a Disney world now with low gas prices, and that's going to change. And I think from the carbon point of view, we have to change it. So to me, you want to get a system that would have long-term economic viability. And to get to the point, we have models, and we've done this now for the state, for different parts of the country, to come up with estimates of levelized cost of heating. That's the real number you need to understand. How does that trade off with how we're heating homes now? Both individual homes, developments, cities such as Utica or Binghamton or places like that. And those numbers are not so far away from what we think we could do in this first generation demonstration at Cornell in terms of productivity from a given set of wells. You saw that well pair. That has to produce fluid at a high enough rate for a sustained period of time to sort of bring that cost to a level which would be acceptable. That's not stuff that hasn't been done before. It hasn't ever been done in this kind of formation. But those typical rates of flow and lifetime are generic to geothermal systems, whether it's in Boise, Idaho, or in Iceland. So I'm very optimistic that if we could get beyond the stage of drilling that first hole, which has some risk to it, and developing a better understanding of the subsurface, it would be just a matter of a few years where we'd have this full-scale operation underway at Cornell. And again, it's, we have to raise the support. That won't come from you heard this from our first speaker, Adam. It's going to have to involve, obviously, a lot of participation beyond the federal government. The states, I think, other entities, whether they're companies or people that see future development in this, would have to be interested in it. But Cornell needs to, put those partnerships together to make it happen. But
thanks, Jeff.
yeah, it's a great question.
So yeah, down at the back. Yeah.
Well, thank you very much. My name is Lara Skinner with Quebec Government Office here in New York City. It's a very interesting panel, so thanks very much. Quebec Government is a partner of New York State in clean energy. And in addition to that, we have companies looking to do business in New York and looking to help. So my question is simple. Who do we contact to help you in some of those projects? Because we've implemented some of those solutions, maybe on a different scale, but in Quebec. And some of our firms here are looking to do business in New York, in geothermal and other source of energy for buildings and campuses, sometimes for the hospitals. So if there's anyone, is there a need, first of all? And if there is not, or if there is, who should I contact? Thank you very much.
Okay, we'll talk after and trade cards. That sounds good. Yep.
John Gilbert, Chief Operating Officer for the Rudin family here in New York. We own and operate a little over 15 million square feet, office and residential. So Trey, I got demand load, electric demand load about 30 megawatts, so definitely interested in buying some of your water-generated electrons. Second, I'd just like to ask the panel and perhaps the Atkinson Center in general, to me there's two pieces here. How do we make more of it and how do we use less? And we're focused on the use less side since we're in real estate. I don't have the ability to generate electricity. So is there research that's being done at Cornell through the Atkinson Center that is ultimately taking the data that we're collecting off these smart meters, perhaps correlating occupancy with fan speed and chilled water temperatures, something that we do at Rudin? And is anybody focusing on squeezing the efficiency out of our built environments while we simultaneously make more clean energy?
Yeah, no, I think it's a great question, and in fact, one of the interesting pieces about New York City in particular is how do you do that in an environment where often the individual tenants are not paying their electric bills, so the normal economic signal's not there. Renters often have utilities included in their spaces, so there are people working on the layers of questions there. How do we disaggregate the energy consumption within a space to understand what's actually being used when and why? And are there ways to reduce it straight up, but also are there ways, which would be a third piece I would add to your description, is shifting when that load happens, because it may be that the grid hasn't got the capacity to give it at 4 p.m., but if that load was shifted to 9 p.m. or 4 a.m., then we're fine. So there's really both those pieces of research going on. How do we use the data to understand why people are using energy and when? How can we get more efficient about it in real time? And how can we move it around so that we flatten that demand curve, which would be a lot better from the supply side as well. So all those things are definitely happening. And in fact, one of the areas I'd love to see more work going on, I'm going to take your message back to my colleagues and beat my drum, is actually on essentially smart large-scale buildings. So it's one thing to talk about a smart home, but to talk about a smart, much larger scale building that can now make those trade-offs in the building and help individuals understand how better that building could be run based on, and how the building can understand individuals, how better to operate within the environment is, I think, a huge opportunity going forward.
Happy to work with you on that. We've actually created a brain for buildings so that we take all this data, we're able to see it and use it in real time, and ultimately wrap machine learning algorithms and some preliminary AI around that, so to prescript and prescribe what, when, and where we should be using this energy, as well as water. You know, the water patterns in multifamily dwellings are fascinating, and they're all different.
Yeah, and they should definitely talk with Lindsay and I some more.
Yeah, there's a lot of, these large buildings, even with the shifting piece, there's a lot of services that could be provided to the grid to firm renewables that are slightly less controllable. But Jeff, you wanted to comment on
so
that.
to add to this too, I mean, the Cornell engineers that are in the facilities group are pretty enlightened and pretty well trained. So they've been able to keep the energy load constant on a campus that's continually retrofitting old buildings that you've seen and growing the total number of gross square feet we have for buildings. So, and they're doing that with essentially information that they've gained from monitoring the buildings, but also strategies. Thermal storage on campus to sort of level some of the both cooling and heating load. The use of other information to just lower the temperatures going to the buildings. We have a steam system now that's providing it. We're going to go, essentially all the buildings are being retrofitted for very low temperature heat. That'll reduce heat losses in the distribution system. Might seem like small numbers. These are big numbers. When you look at the many kilometers of lines that we have delivering hot water or steam to campus. So all of it will be, I think, a good story in the end. You should come and take a look at what's going on the campus too. I think you'd be impressed with the amount of data we have and how they're using it.
Great.
Yep.
Great, thanks. Okay,
Great
so
question.
just in interest of not keeping people too much over, already 15 minutes over, can we take one more question and then feel free to ask the panelists individually? Okay, two more. Okay.
So in terms, it seems that this, my name is Giovanni. I am an educator. In terms of job creation, it seems that this requires certain level of skills. So how these jobs can help to reduce inequalities in low-income communities?
That's a good question.
Can you repeat the last part? How can these jobs help to address inequality
in low-income communities?
In low-income communities? That's a great question, and actually the way that we have been structuring the project labor agreements that I talked about, so the project labor agreement that will be a part of all of the solar and schools work and the energy efficiency retrofits, and now with offshore wind, a part of those project labor agreements is that what you're trying to do is you're trying to forecast how much demand there's going to be for work and job hours, right? We know how much retrofitting work is going to be done. We know how much offshore wind is going to be installed over the next 10 years. So then the training programs can actually make sure that they're training the right number of workers. And then we also attach targets to those training programs. So a certain percentage of the trainees who come into the program have to be women, have to be people of color, have to be from local low-income communities. So I think that's the best way to deal with that.
Thanks.
Okay, last question.
Hi, my name is Gio Can. I work for economic growth and social impact strategy group called Palladium. And my question is, ultimately a lot of the renewable energy industry's electrification of everything is going to have an impact on industries like mining. It's going to obviously drive demand for these mined products. And my question is, what can we do in the smart energy industry do to reduce some of this negative impact that it might have on these auxiliary industries?
We can tackle it. So, I mean, one thing that, if we just take solar, for example, which one thing that we are, actually Cornell is looking at too, and I think the industry is going to have to get better at, is how do you actually recycle panels when they get to their age, their limiting age? They have a lot of elements in them that could be recoverable, that obviously require mining. The same is true on wind turbines and some of the magnets that are involved. So I think a more holistic picture of closing the open loops on these systems as they reach their sort of terminal age and bringing back the system will make a big difference in what we're doing now, which is not necessarily recycling. We're going to have to do this with batteries for sure as we go to a platform that uses much more lithium-ion batteries. And it's a great question because that's where I think life cycle analysis, which is kind of ingrained in us now, at least in terms of what we're teaching, will make engineers and students think through this more carefully. But it's a key point. We have to just do a better job on not just using it and making it efficient, but reusing it and building it to be taken apart and reused and recycled.
Which comes right back to Lera's worker training programs, right?
Yeah, and I'll just say on that point, I was just in Denmark. We were there to learn about the offshore wind industry, and I think looking to places where they've been, developing these industries for a lot longer than we have is really helpful. So in Denmark, we went there to learn about how we do this in New York, and they're like, oh, we're starting to decommission some of our offshore wind farms that we built, 10, 20 years ago, because now we can, because now there's turbines that are 12 megawatt turbines instead of 6 megawatt turbines, so, we don't need to install as many, and they're actually looking at how do we reuse some of the parts of the turbines that we've used in the past, and the new ones are the sizes, 747 Boeing jet can land on just the wings or the blades of these turbines, so they're actually thinking of a lot of different ways that they can use them in the marine industry and other places.
And I'll close by just saying that I think there's a culture of design that needs to change. It's life cycle, not just analysis, it's life cycle design up front, designing for the end of life phase rather than build it and then 20 years from now figure out how do we decommission it.
Right.
So, and we are starting to see some companies think that way. I mean, Apple comes to mind as one of the companies that's really thinking about how do you take apart their devices when they're done.
All right, so thank you first to the audience for your great attention and participation, and then let's thank our panelists for their time and effort for coming here today.